Hello. In this video, I wanted to show you how you can use Descartes' rule of signs to help lower the amount of work needed to find the solutions to an equation. In this video, we'll be working on this equation, which has 2x to the fourth power minus 15x cubed plus 35x squared minus 30x plus 8 equals 0. So in this equation, we can see that it has degree 4, so we should expect 4 solutions, counting complex solutions and multiplicity. The rational zeros theorem tells us information about rational zeros. It doesn't tell us much about complex zeros, but we do know that there will be 4 total zeros. From the rational zeros theorem, we can take a look at the constant term, which is 8, and the factors of 8 are plus and minus 1, 2, 4, and 8, and those make up the numerator of the fraction you see here on your screen. The factors of the leading coefficient, which is 2, are plus and minus 1, plus and minus 2. So from this kind of symbolic fraction we can write down all the possible rational zeros that our polynomial may have. And so they range from -1/2, -1, -2, -4, -8, and then their opposites, the positive numbers corresponding to those negative fractions and integers. And that's 10 possibilities. And if we're going to systematically divide the left-hand side of our equation by the corresponding linear polynomial, then we'd have to do this 10 times potentially to locate zeros. And so we want to see if we can use Descartes' rule of signs to lower the number of possible potential zeros that we would need to check. And so we do that by counting up a number of variations in sign of the polynomial on the left. So what we'll do is I'm going to name a polynomial p of x, and that will be the left-hand side of our equation. So p of x is 2x to the fourth power minus 15x cubed plus 35x squared minus 30x plus 8. Taking a look at this polynomial, we're going to now count up the number of variations in sign among the coefficients. So starting from the left, we have 2x to the fourth power. That's a positive number. The next one, -15. So that is a variation in sign. It switches from plus to minus. Next, -15 to +35. Another variation in sign. 35 to -30, that's from plus to minus, and so is negative. From -30 to +8, that's the fourth variation in sign. From Descartes' rule of signs, there are 4 variations in sign. And so that means that the number of positive real zeros is either equal to that or less than that by a even number. So there will be either 4, 2, or 0 positive zeros. And that's not very helpful. I'm going to spell. Not very helpful so far, okay? We know that there are going to be 4 total zeros. Any complex zeros would have to occur in conjugate pairs, so that's not very helpful. But what we'll do next is we're going to find p of minus x, which will tell us about the number of potential negative real zeros. That will be 2x to the fourth power plus 15x cubed plus 35x squared plus 30x plus 8. And now if you take a look at that, the coefficients of all of the terms in this equation or polynomial are all positive, and so there are no variations in sign. Since there are no variations in sign, that means that there's going to be no negative zeros. Since there are no negative zeros, that means that out of all the 10 possibilities that we had enumerated on the right side, we can forget about all the negative ones. And so we would need to only potentially check the 5 remaining numbers, 1/2, 1, 2, 4, and 8, as possible rational zeros. So I hope that you have found that helpful. If you have any questions on how to apply Descartes' rule of signs to help do what we just did, let me know and have a great day.